Hello there, welcome to Solvebeta today. Now, don't forget, this is still our summer coaching, our online summer coaching, and this class is for grade 10 SS1. 1, 2, 3, 4. Hello there, welcome to Solvebeta. This is our online summer coaching program, and this class is for grade 10, also known as SS1. We're going to be looking at this topic, very, very important topic, known as indices. 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 Now, what is the word indices? What is the meaning of the word indices? The word indices is the plural form of the word index. It's the plural form of the word index. Now, before I proceed, the purpose of this lesson, what I want to achieve with this lesson is to teach you what is the meaning of index, how to solve problem involving indices, how to solve different problems involving indices, because there are a lot of forms it can come, how to solve problems involving indices. So that's the goal of this lesson today. Now back to the lesson. Index is this singular form of indices. What we mean by singular form here in SS1, so there are some terminologies that I would expect that you are familiar with. But singular means one, plural means more than one. So if it's just one we are dealing, we'll call it index. While if it's more than one, we'll call it what? Indices. Now, a number 2 raised to power 2, 2 raised to power 2, or 5 raised to power 9, you have a number written in this form. You have a number, then a small number at the right hand side. Now this is called the base, while this is called the exponent, or we say power, the power of this. So this 2 here, this 9, can either be called the exponent or the power. Are you seeing it? 2 to the power of 3. This is the exponent, the power. Or it can also be called the index. Index. We say that if it's written like this, written in index form. Don't forget, this 2 is the base and this is the what? Exponent. So I'm going to put it this way. If you have terms that are written like this, we say they are written in index form, where this 2 is the exponent and this is 2 to the power of this 2, 5 to the power of this what? 9. What this simply means is this: 2 to the power of 2 is simply 2 in 2 places. This base in 2 places. The base in 2 places, or the base in the amount of times this power is given, multiplied by each other. And let me simplify that. If you have 3 raised to power 4, it means that the base 3 will be multiplied this time 4 times by itself. Are you seeing it? So this 3 raised to power 4 is 3 base here multiplied by itself 4 times. 1, 2, 3, 4. Are you seeing it? So this also can be 3 times 3, 9. 3 times 3, 9. 9 times 9, which is what? 81. 81. So 2 times 2 is 4. So it means that 2 raised to power 2 can be simplified to 4. While 5 raised to power 9 is 5, 1, 2, 3. You write it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's it. Don't forget, this one, the number above that is smaller is the exponent, while the bigger number is the base. Together it is called 2 raised to the power of this, or we say that it's in index form. This form is in index what form. Then when you have these 2, we say they are both indices. They are both indices, more than one indices. Take that and done justification to that. Don't forget the terminology. I'll be using them in the class. Now, index singular. Singular. Let me put that there. Singular. There are certain laws guiding solving problems that have what? Exponents or indicia problems. There are certain laws. Why are these laws important? Those laws are important because you have various questions that can come. Okay, various questions that can be asked to solve here. For example, look at this. If you have this 2 raised to power 3 times 2 raised to power 4. When we have the same base and you have a number, this is the base 2, you have the exponents to be 3, multiply by another number in the same base but with a different exponent 4. These two, they are in the same base, 2 and 2, but they have different exponents. When you ask to multiply them together, to simply do that, you say 2, you pick one of the base, then you add the power. Because this is multiplication, you add the power. 3 plus 4, which is what? 2 raised to power 7. So it means that 2 raised to power 3 times 2 raised to power 4, it is 2 raised to power 7. This is called the multiplication law. Multiplication law. This is called the multiplication law. It's called the multiplication law. 2 raised to power 3 times 2 raised to power 7. Now, why does this law work? It works because this base, they are the same, but they just have a different power. The same base, different what? Power. Now, the law does not work when you have different bases. 2 raised to power 3 times 3 raised to power 3. These bases are different, so this law does not work. There's another way to solve this problem, which does not involve the use of this law. And what is the law? When you have the same base and you have to multiply them with different power, you add the power together. So let's take another. It could even be a letter. It can be a raised to power 3 times a raised to power 0. A raised to power 0. So this will be a raised to power 3 plus 0, which is a raised to power what? 3. The same base, different power, add the power. The same base, different power, add the what? Power. That's the multiplication law. Then we can simplify our answer further. Let's say we have 10 raised to power 2 times 10 raised to power 3. You know that because you have the same base, you say 10 raised to power 2 plus 3. You add the power, which is 10 raised to power 5. We can simplify this 10 raised to power 5 to be 5 zeros. 1, 2, 3, 4, 5. Or you can write it as this. Remember what I taught earlier. 10 times 10. That's 5 times 10 times 10 times 10. 1, 2, 3, 4, 5. Why is it 5? You have 1, 2, 3, 4, 5. 10, the base, 5 amount of times multiplied. So this will be 10 times 10, 100. 100 times 10, 1000. 1000 times 10, 10,000. 10,000 times 10, 100,000. 100,000. Then this also can be simplified, but I'm going to leave it like that. Leaving like this means that we're leaving it in index form. So let's go to the second law before I rub this off. It is the division law. Don't forget, this is the multiplication law. Division law is the opposite of this, meaning that if you have this, let me demarcate. So you have, let's say you have 2 raised to power 3. Now it's no more multiplication, division divided by 2 raised to power 4. That is called the division law. That's why it's called the division law. 2 raised to power 3 divided by 2 raised to power 4. And let me use the exact example. 2 raised to power 3 divided by 2 raised to power. Let me not use the exact example. Let me use 2 raised to power 1 because I don't want to introduce something else. I'll say refer back to the one I introduced that. 2 raised to power 3 divided by 2 raised to power 1. So division here, unlike multiplication you add the power. Division here you subtract the power. Division is the opposite of, or is the reverse of multiplication. Addition is the reverse of subtraction. You can use that to memorize it. 2 raised to power 3 minus 1, which is 2 raised to power 2. So when you have the same base and you have to divide them when they have different powers, you say 2 raised to power 3 minus this one here. 3 minus 1 is 2. You can simplify this further to be 2 times 2, which is 4. You can leave it like this. So let me take another example. You have 4 raised to power 10 divided by 4 raised to power 6. Please take note that this division law works when you have the same power. Sorry, you have the same base, not the same power, the same base. The same way this multiplication law works when you have the same base. That if it does not contain the same base, there's a different way to solve it, which does not involve the usage of this law. So you have 4 raised to power 10 minus 6, which is 4 raised to power 4. And please kindly note that in writing this exponent, to write the exponent, it must be smaller than this base and it must be at the right hand side. Don't put it at the left hand side. Don't do this. Don't write it this way, no. And don't write it this way. Let the power, the exponent, let it be noticeably small at the right hand side. Right hand side, top right hand side of this number. Top right hand side, like a superscript. Top right hand side of this number. Don't forget you can simplify this or you leave it like that. So these are two laws. I'll be referencing this division law and the multiplication law. Division law and multiplication law. And if I'll be referencing it, multiplication or division law, so that you can get. So write this down. Let me rub this off. Then we go to the third law. Now this third law is, we can call it bracket, law of brackets. Meaning that if you have this a raised to power b, you have a bracket raised to power c. Please take note that these two b and c, these b and c, these two letters b and c, they are exponents one, and you have a bracket to separate them. Or let me give you another example. 10 raised to power 2 bracket 4. Now there are no two bases here, right? But there are two powers separated by a bracket. To solve this problem, what you do is to multiply the power. It's called the law of brackets, or law involving bracket, law of brackets. Please don't be particular. Don't focus on the how we term the law or what we call the laws. Just know what it involves. So to solve this, you multiply a open brackets, a raised to power b open bracket close bracket and c. You multiply this b times c, which is same thing as a raised to power bc. In algebra, b times c is same thing as bc. B times c same thing as bc. So it will mean that if we're using numbers, this will be 10 raised to power 2 times 4. What's 2 times 4? 8. 10 raised to power 8. 10 raised to power what? 8. So this is the law involving bracket. 10 raised to power what? 8. 10 raised to power 8. The law involving what? Bracket. 10 raised to power 8. 10 raised to power 8. So one more example, one for the root. If you have 3 raised to power 5 raised to power, let me use 0. So it will be 3 raised to power 5 times 0, which is 3 raised to power 0. Now look at this 3 raised to power 0. It will then bring me to the last law we're going to be looking at in this class. In the next lesson, the next class, we would see some other laws, but we're going to stop here. 3 raised to power 0. There's a law of zeros. or law of powers of zeros, saying that when you have zero zero how do I put it? Zero, when you have zero power. Please, some other people might not express this law the way I'm expressing it. When you have zero power, something like this, 3 raised to the power 0. Anything raised to the power 0 apart from 0 itself, or any non-zero number raised to the power 0. Let me put that way. Any non-zero number raised to the power 0. That if you have a number that is not 0, that's the base, but the exponent is 0, it is 1. The solution is 1. That's what this law is saying. Let me differentiate these two. This is the law of bracket, why this is the zero power law. That means if you have a number that is not 0 and is raised to the power 0, the solution is 1. 3 raised to the power 0 is 1. 10 raised to the power 0 is 1. 500 million. Let me write that. 500 million raised to the power 0 is what? 1. 1 raised to the power 0 is what? 1. Now this is not true for 0 raised to the power 0. 0 raised to the power 0 is not what? 1. 0 raised to the power 0 is not what? 1. Actually, don't worry about that. Don't worry about that. Let me focus on this. So any non-zero number raised to the power 0 is what? 1. 2 raised to the power 0, 1. 3 raised to the power 0, 1. 4 raised to the power 0, 1. 1 million raised to the power 0 is 1. 1 raised to the power 0 is what? 1. So you see that we can then simplify it. If you are this, let's say you solved any problem and you get to 3 raised to the power 0, you can just write it as what? 1. You can just write it as 1. So these are 4 laws of indices we have looked at today. The first law, the multiplication law. The second law, the division law. The third one, law of brackets. Why this one is zero power law. Zero power what law? Now, how do we apply them? How do we apply them? This is how we apply them. We can have problems like that. I'm going to solve examples applying the 4 laws we've learned today. So you can write this down. How do we apply them? Let's say you have this. You might have this. Examples. You might have this. Three raised to the power 4 divided by 3 raised to the power 4. I'll show you why this is 1. Using, the fourth law says that anything raised to the power 0 is 1. Any non-zero number raised to the power 0 is 1. So, and the second law, the division law, says that when you have the same base and you have to divide them, you subtract the power. So this will be 3 raised to the power 4 minus 4. Which is 3 raised to the power 0. 3 raised to the power 0. Anything raised to the power 0 is what? 1. Are you saying this? Are you saying this? Then, why is it also 1? Any number divided by itself is 1. Again, 2 divided by 2 is what? 1. Why is 0 divided by 0? Is it 1? No, let's leave 0. But any non-zero number divided by itself is what? 1. Are you following me? So, the reason why this is 1 and this is also what? 1. This is why this is 1 and this is also what? 1. Are you following me? So what if you have this another example? If you have this, 4 times 4 is to the power 5 raised to the power 2. Again, to solve this, we're going to first solve for what's in the bracket. We're going to first solve for what's in the what? Bracket. We can do it 2 ways. We can solve for what's in the bracket, saying, remember this 4, there's no power. If a number does not have a power, it's actually raised to the power 1. 4 does not have a power, a visible power, a visible exponent. It does not have a visible exponent. It's 1 that is the exponent times 4 raised to the power 5 raised to the power 2. So we can move further to say that this is when you have the same base, different power, you add the power 1 plus 5, which is now raised to bracket these two. I've used the law of multiplication here, so I have 4 raised to the power 6 bracket 2. The law of multiplication has given me 4 raised to the power 6 for this inside the bracket. Then law of brackets says that you multiply this 4 raised to the power 6 times 2, which is 4 raised to the power 12. So answer is 4 raised to the power 5. You can simplify this, but it's going to give you a very large, a very great number. So you can just stop here. This is the first way to do this. You can do it this way. I think this is the easiest way to do it. You can do it this way. You can do it this way. Or I think I can rub this off to show you the second way to do it. This is the first way to do it. Now, this first way involves you using BODMAS. What's in the bracket? You solve for what's in the bracket. Or PEMDAS, anywhere you know it. Anyway you know it. PEMDAS, parenthesis. Use what's in the parenthesis, what's in the bracket. You solve for it first. How do we solve for it? We said that this 4 is raised to the power 1 because when there's no power 1, when there's no power here, it's actually raised to the power 1. 4 raised to the power 1 times 4 raised to the power 5. The same law of multiplication, the same base, different power, add the power together, add the exponent together. 1 plus 5, 6. 4 raised to the power 6, open bracket, close bracket, then raised to the power 2. Law of bracket, you multiply the 6 and 2. So you have 4 raised to the power 6 times 2, which is 4 raised to the power 12. Another way to do this is to say, you can say in a number multiplied by another number square can be written as it can be written as a squared times b squared. You can write it like this. Yes. So it means that 4 times 4 raised to the power 5 square will be 4 square. 4 raised to the power 2 here. 4 raised to the power these 2 times 4 raised to the power 5 square. Can do it this way. 4 raised to the power 2 here times 4 raised to the power 5 upper brackets square. So I'm squaring this one first times this one word square. So this will be 4 raised to the power 2 times lower bracket 4 raised to the power 5 times 2, 10. And this will be 4 raised to the power, the same base, different power, 2 plus 10. This is 4 raised to the power 12. So you can do it this way, you can do it this way. You can do it this way, you can do it this way. So I'm going to stop here and I'll give you an assessment to do. I'll give you something to assess whether you understood what I've taught in this lesson. So the assessment is coming now. Okay, try this. I want to rub this off. Try this. Try this. Number 1. I'm going to make at the 4th question. I want to test your intelligence. I want to test your intelligence. The 4th question, or rather the 4th and 5th question will test your intelligence to see 2 m raised to the power 5 divided by 4 m raised to the power 4. You test your intelligence to see if you can think, or I think I will just give an example like this. So I wouldn't, should I make you think? I think I should make you think more. Okay. So if you have this, so for this, let me give you something. Let me just give you an example. Or should I make you think? Okay, let me give you something that will guide you to do this one. Now, if you have something like this, 27 p raised to the power 5 times 27 p raised to the power 5 times 3 p raised to the power 2. Now, what you do is this. You see that this p, they have the same base, different power. You can say 27 times 3, you separate the number from this p, then p raised to the power 5 times p raised to the power 2. You can do this. 27 times 3, then times p raised to the power 5 times p raised to the power 2. 27 times 3, that should be 51. No, sorry, 81. 2 times 7, 21. 2, 3 times 6 is 81 times law of multiplication. P raised to the power 5, the same base, you add the power. 81 times p raised to the power 7, which is 81 p raised to the power 7. According to algebra, 81 times p raised to the power 7 is same as 81 p raised to the power 7. So the thing is, you have to separate the numbers, operate on the numbers. Let this operation multiplication be done on this number. That will multiply the numbers separately. Then when your answer, you will later join it to this indices here. So that's what you do for this, and you do for this also. So I've been given how many assessments? 1, 2, 3, 4, 5. So please make sure you take this assessment. I would check your notes. So take this assessment and do it. So thank you for this. I'll see you in the next one.